Welcome to the last week of Geo-Python. It's, well, I don't know. It always feels like fairly intense for me as a teacher, so I would imagine it's fairly intense for you as a student as well to go from potentially knowing almost nothing in Python or about programming it at all to now doing data analysis using the Pandas library, and this week now transitioning to doing some data visualization using Pandas and a library called Matplotlib that we, I think, saw briefly in one of the earlier lessons. I don't remember maybe which one. But doesn't really matter, we'll get there. But we can start with our poll response, questions, answers, whatever here. And, I would say that this is looking at first glance like pretty representative feedback. So Pandas seems extremely useful. However, there's so many ways to do things that the amount of information is a bit overwhelming. I think this holds true actually for a lot of things in Python, to be completely honest. There's often many ways in which you can solve the same problem, and sometimes even with the same tool, there are more than one way in which you can solve things. So like last week when we saw this iter rows approach to kind of go through and calculate something row by row in a data frame in Pandas, of course, we then also saw that you could do the same thing using other approaches. And that I think what you'll find is as you get a little bit more familiar with doing things using Python or using Pandas, you'll find your preferred way to do things. And sometimes it might not be the fastest way to do it, but it's the way that makes sense to you. And quite honestly, if it's the way that makes sense to you and it works, a lot of times it doesn't matter if it's not the fastest approach. So if you understand the iter rows approach and say, okay, I get this, that I could use this, and another approach doesn't seem to make sense, then there's really, for the kind of applications we're typically dealing with, efficiency is not necessarily the number one focus at this stage in your learning to program. Some other things here just about kind of, I would say maybe growing pains in working with Pandas. So feeling like you made things more complicated than they had to be. Unfortunately, that's probably the case, especially when you're working through some of the exercises that you may come up with a solution again that works, but might be quite complex. And there's a simple and elegant solution that may exist. But again, we're at the stage where the most important thing is to get things to work and to be able to calculate your solutions. And we can worry about making it more pretty later. This comment here about managing and manipulating multiple data frames being somewhat confusing. Of course, it's like that anytime you start taking a subset of your data from maybe the file that you've read in, it does take a bit of attention to keep track of what is in which data frame, especially if you give the data frames names like selection, which might not be intuitive. So you could think about that from the perspective of the variable names you use when you take something out of a data frame. If you're taking data for 1 month of 1 year, then maybe you should call that data frame June 2014 or something like that to make it clear what it was. This is also the point typically where people are noting that the exercises are more demanding compared to the earlier weeks and that these exercises were very hard. On the scale of 1 to 100, weeks 1 through 5 went from 1 to 5. Week 6 went from 5 to 9,000. Also a representative feeling based on years past in the course because, we do push you a little bit harder in the last few exercises because, I think we basically want to show you the potential of what you can do using Pandas. And again, I would try to encourage you to use the resources you have available when you get confused about things. And please ask questions in Slack and attend the exercise help sessions because, we don't want you to feel like things are going from 5 to 9,000 in 1 week. But I do understand that, it is a big jump. especially in like really weeks 5, 6, and 7 are definitely more challenging than the first 4 weeks of the course. This week, I would say that the exercise is probably not quite as big of a jump as it was in week 6. So hopefully you'll find that to be the case. And yeah, I think this is sort of fairly clear picture of how things are going in general. And again, please feel free to ask questions if you have them, both in Slack, in the exercise sessions, and I mean, of course, when we take a break today, you're also welcome to come down and ask any questions you might have then. Before we move on, is there anything anyone else wants to add here? All right. So with that, then, let's take a look here at the course page, make this a little bit bigger, and hide the navigation links, which I shouldn't do until I actually get to our overview page. So here we are, lesson 7. And the focus for today is basically going to be on data visualization, really just getting some basic introduction to how to do some visualization of data using Pandas and using the Matplotlib library. We'll also take a look at how to make an interactive plot using a plotting library called HVplot. That's part of HoloViews. That's just kind of like an optional little thing, but it's always nice to see that you can do that. And after this, you should be able to do things like make XY plots of the data that you're dealing with in a data frame, manipulate various elements of the format of the plot, and I would say in here what's maybe not listed is also to be able to create groups of plots in a single figure, and then how to create these plots in a notebook and save them to image files. So that's where we're going for today. Now, looking at the kind of landscape of plotting in Python, and maybe I'll make this, I don't know how much bigger I can make that. I guess I can't make it much bigger. For whatever reason, this doesn't want to zoom in nicely. But on the course page, you'll see that we have this image that actually takes you to a website. Maybe that'll be something I can zoom in a bit better. It just shows you the way in which all of these different plotting libraries in Python relate to one another. So the first thing you can take away, of course, from looking at a picture like this, where each one of these boxes represents some kind of Python plotting library, is that there are many different options out there for how to plot your data in Python. And this can be sort of like with Pandas, a bit overwhelming when you first start poking around in this landscape, trying to figure out, what do I actually want to use to plot my data? And for us, the starting point will be, we're going to use what's available in Pandas to begin with, because that's easy. And it actually is based on this library over here in blue that's sort of the source of many libraries that have split off from it, called Matplotlib. So that's the kind of OG Python plotting library that many things have come from, including Pandas, as you can see here. What's cool about the page here, if you're interested, is that all of these little boxes are links that you can click on to read more about some of the libraries that have come from things like Matplotlib and how they relate. So you're welcome to kind of take a look around here if you're interested. What you'll find on the course page, I'll just make that a tiny bit smaller for the moment, is an overview of the libraries that are what we would consider maybe the most common libraries for doing plotting in Python. So of course we have Matplotlib here at the top. And with each one of these, you have a link to the project site for that library, as well as a link to the gallery of some example plots. So if you click on the link to the Matplotlib gallery, for example, you will find example plots of different styles that you can not only kind of get a sense of, oh, how do I do, this kind of plot if I want to do it in Matplotlib? You can kind of look through and find one that looks something like what you might want to use. So let's say like this kind of scatter plot with histograms, which looks like this. So when you click on one of the example plots, what's actually really nice about the Matplotlib website is they also provide you with a little code snippet that will reproduce this plot. So if you want to make a plot that looks something like this, this is a kind of nice jumping off point, because you can go here, copy this into a Jupyter notebook, and produce a plot that looks like this, and then start tinkering with it and adjusting it to do whatever it is that you want to do. So since I said that is the case, I'm going to go here to Jupyter Lab. I've already opened up my my CSC notebooks environment. Let's see if we can test this out, just because there's no reason not to. Maybe that's big enough. So we'll get into dealing with this stuff in the lesson, so don't worry about this part right now. But I'm just going to import the Matplotlib PyPlot library, which is the main library that's used for plotting, and let's just see if this works with the example here. Scatter hist is not defined. Okay, I must have done something wrong. Maybe I need to import some other thing from Matplotlib, or actually need to copy the entire code snippet, not just the piece at the bottom there. So let's try that again. Copy in the other piece that they had defined some scatter hist function in this example. And now let's see what happens when you run it. So there you go. Nice demonstration that what they have on their webpage does actually work. And again, actually for the kinds of plots that I'm often generating using Python, this is one of the places where I will go to basically get a starting point if I don't have the sense already of how to produce a plot. And I've done plots that look something like this in the past, and yeah, this has been really helpful to be able to go and get a working example from the Matplotlib documentation. So we have Matplotlib. Matplotlib has as noted in the way that this little network diagram is showing the plotting libraries and how they relate. Things like basemap, which is a library that had been one of the ways in which you can make map plots using Matplotlib. So it was kind of focused or designed for using geographic data. Note that now this basemap project is being deprecated or sort of is no longer going to be actively developed in favor of another library called Cartopy, or Cartopy, I guess, maybe if they want that to have the Python emphasis there. But again, you can find that info about that library and a link to its gallery here on the webpage. Seaborn is another plotting library that I think, among other things, makes really nice looking plots. So again, you can go check out the Seaborn gallery to see the kind of style of plots that are available. And I think that, like Matplotlib, yeah, you can also see examples of how to produce those plots from the Seaborn page's documentation. When it comes to those libraries so far, they're all pretty much for producing static plots. Of course, you can produce animations using Matplotlib, but not things that are interactive. So interactive plotting is something that's better handled by libraries like Bokeh or Plotly. And again, you can find examples of those libraries' documentation and galleries. So like for Bokeh, for example, they have some nice things where you can check out ways in which you can produce little web applications, where you could, for instance, select different values that you want to plot in your plot here and have an interactive version of a plot that can be shared online. And these, if you produce them in a Jupyter notebook, will be interactive in the notebook, and there's also ways to make interactive plots that work on web pages as well. And in fact, like for our course web page, the interactive plotting example that we have is generated from a Jupyter notebook and converted to a web page and works just fine as an interactive element on our course page. So yeah, that's really nice because, of course, it's great to be able to do things like interact with the data in a little bit more intuitive way. Some of the examples for the bokeh will have like sliders that allow you to do things, but even without that, you have the possibility to go and click and zoom into areas of interest. And of course, this is one way in which if you want to share some visualization that you've produced with other people, not only can they see what you've done, but they can really begin to get more of an understanding of the data that they're working with, because you can do things like mouse over the points that are in here and see information about the data values that are in the plot. So that's a really cool thing about bokeh, and Plotly is working similar in some ways in terms of the output that you get to bokeh. There are a few other examples here that are described, including holoviews, which we will use ourselves in making our interactive plot. But these are, I think, in some ways designed to make it easier to take the plots that you would produce using something like Pandas and make them interactive. So that's exactly what we'll do with holoviews, is essentially just drop in one small change to how we would plot things to produce an interactive plot without having to modify anything else with our Pandas plotting. So we'll see how that works when we get there. The point here is just that if you want to get a sense of like some of the main plotting libraries and some of the ways in which you can produce different styles of plots, you have it here on the course page, and we would encourage you to have a look. And again, it's also worthwhile to go to this linked page here and check out the relationships between some of these libraries. Yeah, I think that's maybe it for the overview of the different kind of landscape of plotting in Python. And before we go to our lesson topic for today, there's one other thing we should talk about here that's probably already somewhat familiar to you, but is described on the course page because mainly there's some terminology that we want to clarify. And this has to do with the anatomy of a plot. So it's essentially driven by the question of like, well, what actually is a plot when we refer to a plot in Python? And there's lots of different styles of plots. You can see, for instance, here, scatter plots, bar charts, things that you've already been using yourselves most probably and are familiar with. These are all just, I think, links to the Wikipedia article about a scatter plot. So you can go and, if you've never seen one before, read some information to see what a scatter plot is. Probably this is not the case that you've never seen a scatter plot before. But it might be the case, for instance, that you haven't seen a chord diagram previously. And so then maybe you would want to go and say like, okay, what is this? And you can get some information and see some example plots of chord diagrams from the linked pages here at the start of this part of the lesson. But what's more important, perhaps, is to talk about some of these different things that are labeled on the figure here from the course page, because these are terms that we're going to use in talking about the plotting that we'll do, and also when you want to make modifications to some part of the plot, if you want to be looking around in some search engine, these are the terms that you're most likely going to want to be searching with. So, we've all seen plots before, of course. In this example, we have some kind of few different lines that are plotted, one in red and one in blue. And so, of course, the line that's plotted itself is just referred to as a line. That's intuitive enough. The space in between the two lines in this case is filled with this kind of pinkish color, and that's what's called filling, or the fill. And you can see a lot of other things on here that you would normally have on a plot, like a title, some kind of annotation. You can see grid lines, for example, here, a legend. These are things that are maybe already familiar to you. However, maybe you're not familiar with using the word padding, for example, to specify how much space there is between the axis line and the axis label, for example. So on the y-axis here, If you wanted to have more space between the text and the line, you would be adjusting the padding in producing your plot. You probably also know that these little thin line segments that are along the axis perpendicular to it are referred to as ticks. And again, you can format the ticks in Matplotlib plots. You can also change the tick labels and, of course, the axis labels themselves. So these are all different pieces of what we could consider part of a plot, along with the name that you would typically use when searching for how to modify those in a plot in Matplotlib. So all of these terms are summarized in this common plotting terms table from the course page. So if you have any question about what something is, you can find information here, for example, about line width, which is the parameter that's used oftentimes in plotting with Python to specify the thickness of a line, or line style, which can be used to specify whether a line is solid or dashed or dotted or whatever. So again, you're probably already familiar with this idea of what a plot is, but we wanted to make sure that we provide some reference for what these different names are so that you know where to look when you want to modify your plots. All right, so that takes us then, I believe, to our first part of the interactive bit of the lesson, which is about basic plotting with Pandas and Matplotlib. So if you haven't already done it, I'm going to get rid of a few tabs here. If you haven't done it already, you should now open up your CSC Notebooks environment and head to the My Work directory and then into the Notebooks folder that is there. I'll also maybe close this one. So just like the past several weeks, once you're in the My Work Notebooks folder, you can go to the Git plugin, and you should see that there are some changes that are ready to be pulled down from the server, from github.com. So you can click the Pull Cloud button to grab the latest changes, which would give you this L7 directory that should be missing most likely when you first go to that directory. If anybody's having trouble, maybe just let us know. Fortunately, Christoph's here today, so if you're having trouble, he may be able to assist you. But for those who aren't having any trouble, you should now see when you go back to the file browser that there's this L7 directory that wasn't there before. So you can double click on that, and then we're going to open up the first notebook here called Matplotlib. And I will now hide the file browser just so we don't have to see that. And yeah, so we'll get started with our basic plotting lesson at this stage. And so there's some introductory text here at the very beginning that basically says that with Pandas, just like we had mentioned earlier, that under the hood it's using this library called NumPy to do some calculations and things that are very efficient whenever there are operations that are applied to calculate something in a Pandas data frame. NumPy is essentially what's being used in the background. And similarly, we have Matplotlib hiding under the hood in Pandas for plotting, which will allow us to do some basic things with plots, and we'll start out that way. But at some point when we get into really wanting to control the formatting of the plot in more detail, we're going to have to use Matplotlib more directly. So we'll start out, see how far we can go with Pandas plotting, and then we'll introduce Matplotlib at that point. Just like last week, we're going to be using this weather data from the NOAA online database. It's actually the same data set that we used for lesson 6, so we don't need to do anything to be able to access it. And that, I think, should mean that if you're using the CSC notebooks, you don't need to do anything at all. Again, if you're working on JupyterLab that's been installed on your own computer, then you can find some instructions about how to download the weather data back in lesson 6. The description about the data here is, I think, maybe exactly the same as it was for lesson 6, which perhaps doesn't come as any surprise since we're using the same data. Again, you can go and see, for instance, the list of stations that we have data for in the data set, details about what each one of the column headings means, and other things about sort of how many observations each station has in the linked metadata files here. And I think the formatting of this looks kind of weird on the course page, but what you'll see is, well, I don't think it looks any better like this, actually. I don't think I can make this. Yeah, I can't unwrap the words here. So anyway, our data file, if we go and take a look at one of those, would look like this. We looked at this last week, so there's not really a need to go in here in any detail at this point. So let's then get started. You can do that just by running the first cell here, which is going to allow us to import pandas. And we're going to import pandas as PD, as is the sort of tradition for using the pandas library. And this time, before we read in our data, it's worth noting that we are going to use this date time approach in dealing with our data this week, which is going to mean that when we read the data in, we're going to read it in slightly differently than we have for some of the earlier lessons. And let's see what that is meaning in our case. Well, we don't have to do anything different here to read in or to define the file path. This is just going to tell us where you can find the data file, which you'll notice is going back to lesson 6, and the file we're using in this case is this 29740 .text file. I'm actually wondering, is that the wrong one? Going to take a quick look. I may have made a little bit of a typo because I don't feel like 29740 looks like the right number. No, it is okay. 29740. Okay, never mind. So, yeah, so that if you run the cell here to define the file path, that will define the location basically of where the data are that we are going to be using. And then the cell underneath here will read it in. You don't need to modify anything here to be able to read in the data file. But I'm going to note two things here that are different than before. One, now we have this parameter called Parse Dates. This is going to then have with it a Python list that contains any column where there's a date information that you would like to be automatically converted from, for instance, text to being a date time index or date time value. So we have now this column that we had before with this yer, mo, da, herm thing, which was the 4 characters to indicate the year, 2 for the month, 2 for the day, 2 for the hour during that day, and 2 for the minutes of that hour. So we have the parse dates thing, which is just telling pandas that when you read this in, this column contains dates, and you should try to convert those dates to a date time. And then in addition, we're defining this parameter called index call equals, and then we've given the name of that column containing the dates. What that's going to do is rather than start like setting the index to start at 0 and go 0, 1, 2, 3, and each row gets an increasing integer value, it's going to actually set the index to be the date. So there's reasons for doing this, and we'll see that in a moment. But if you just run the cell here, it'll take a minute to read the data file in. Actually, reading the data file in is fairly fast. Parsing the dates takes a moment to convert from text to a date time index. But this will take, I don't know, 30 seconds or something like that. In case you're curious, you can find the information about the two parameters I've already mentioned down here in the box underneath where we're reading in the data. And as soon as that is done, we will take a look at the data that we have read in. I thought this would take 30 seconds. Maybe it's a little bit longer. But yeah, the key thing here is that what we want to be doing in dealing with our data for this week is to have index that is linked to a date so that we can do things like select ranges of dates more easily, which you'll see. It's also nice for the plotting if we have the index as a date. So now that things have been read in, at least on my instance here, you can then do data.head. Again, you don't have to type this in. It's already in the cell there for you. But what you'll notice now is that the text on the left in the first column, which is indicating the index, has the sort of heading that we had before for our date information. But you can see the formatting here is not this sort of 4 characters for the year, 2 for the month, 2 for the day, blah, blah, blah. But instead, you can see that this has actually been converted to a date that's being represented using the datetime library. So we have here, for instance, the first day in our data set, 1952, 1st of January at midnight. And then we have, of course, a selection of columns. Why do we have a selection of columns? Well, that's because use calls here was defined in reading in the data file to take only things related to temperature because we didn't need other values in this case. So you can see we have temp, we have max, and we have min, where temp would be the kind of average temperature for that day. Max, of course, would be the maximum temperature that day, and min would be the minimum temperature. All, I think, fairly intuitive. All right, so let's make a plot. And we can do that by typing AX equals, and then we'll do data.plot. Strictly speaking, you don't necessarily need this AX equals part. However, it's useful to do this because it allows you to control elements of the plot format after you produce the plot. Data is the name of our data frame we've just read in, and .plot is a method in Pandas that allows us to plot that data. So if you run this cell, you should hopefully see that after a few seconds, you'll see a plot here. Maybe more than a few seconds, but there it is. And what you can see in this case is, well, we have things that look a little bit like sort of wiggly lines for our temperature in blue. And there's also some little line segments you can see here in different places in orange for the max, and there's then some green dots you can maybe see on your own screen that are for the min temperature. As you notice, perhaps, when we saw what the data looked like here, when we did the data.head command, there's a lot of missing data in the max and min columns, so you don't get nicely connected lines as you might expect to see. However, for the temp column, there's much less missing data, so you have what look like more continuous little line segments. We'll zoom into this data in a second to take a look in kind of closer detail at what we have. But we've got variations in temperature. You can see, for instance, here, if you look along the x-axis of the plot, we're going from 1950 to 2020 in terms of the range of dates that we have here. So our date column is actually being used as the x-axis value, and then all the other columns are plotted on the y-axis in this case. You'll notice that in our example here, maybe between like 1964 and 1973 or something like that, there's missing data. So this line that's here, it's not that the temperature, of course, was constant during that time period, but simply that there's no data during that time. It's missing from the records at this weather station. So yeah, that's the way in which we can produce a very simple plot, which is simply the name of the data frame and then .plot. So you can again see what we have here. We've assigned this to the variable called AX. So if we check out with the type function what type of thing AX is, you'll see here that even though we did data.plot, which is a method in Pandas, the object that comes out of here is a Matplotlib set of axes. So we are seeing proof here that Matplotlib is being used by Pandas because the object that's produced when you generate a plot is a Matplotlib object. All right, let's now take a look at some ways in which we can start to zoom into the data that we have and also to manipulate our plot to do some formatting things like that. And here, let's just take a look at data from the afternoon of the 1st of October, 2019, which is the last day in our data set. We'll do this by making a selection of the data where we can say our oct1 underscore temps. So temps. So temperatures for the 1st of October equals data, and then we'll just grab things from the temp column of our data frame at the location or locations where data.index is greater than or equal to, and then in here we can put 2019 10 0 1 and then 12 0 0. So that's noon. And so again, just to highlight it, 2019 is the year, 10 would be the month, 01 would be the day, and then this is 12 o'clock, so midday on that day and 0 minutes. So what this is going to do is take from the temp column of our data frame, data, any place where the data index is greater than this character string here. And the character string is going to be interpreted as a date when we do this comparison. So our index in this case, as you might remember, is the date. And this will then allow us to choose only the times that are greater than or equal to this time here. Okay, we only want things out of the temp column just because we want to keep it simple. And the data index selection is based on this time that's given here. And by doing this, we can then do things like type oct1 temps.plot to plot the data for only that selected range of times. Again, there are multiple ways that you could do this, but this is maybe the simplest way for us to work with it. So I'll run that. It's going to make our selection, and then we'll set up our plot here. So let's start with AX equals oct1 temps dot plot. We're going to add some stuff in here this time, though, for our plot. So this doesn't need to be indented in here. It stylistically often is. But we're going to format our plot first by giving it a style. And our style in this case, we will make a red line instead of whatever it was, blue, I think, by default, by putting the letter R here. We'll plot the data points as well by adding an O. So I'll talk to you about where this RO thing comes from in a second. And we'll make it a dashed line by adding 2 hyphens or dashes after that. That's going to set up our line format and the style of the line. And again, I'll elaborate on that in just a second. In addition, we can add a title. And let's say Helsinki Vanta temperatures. So you use the parameter here called title equals, and then you give a text string. If you want, you can make this an F string and put things in there. But you know, it's for our case here, there's no need to use any F string formatting because we don't have any variable name that's being put in here. But yeah, we can do it like that. We can also add a label for the x-axis. So we could say the x label equals, and we could say date, for example. So we want to make our plot easier to understand. It's a good thing to do is to put a label on both of the axes. So let's also then make a y label. And our y label in this case can be temperature. And if you want to be fancy, you could make your temperature in degrees Fahrenheit. I don't know how you make this symbol on other keyboards, but at least on the Finnish keyboard, it's Shift and then the key left of the 1. I think maybe on others it's going to be different. So you don't have to do that if you don't want to add the degree sign. You could just put F. I think most people, of course, would understand that. But we'll make our label there temperature in degrees Fahrenheit. So we got 4 things here that we've now specified for how to format the plot. We're formatting the style of the line with this command. We're adding a title for the plot itself and then labels for the X and Y axes. If you run this one, you'll see things are a little bit more nicely formatted now than they were. So you can, for example, see already, here's our title for the Helsinki Vantaa temperatures. We've got our axis label here on the y-axis for the temperature in Fahrenheit, axis label here on the x-axis for the date, and then of course the star of the show is our lovely dashed red line with the red circles for each one of the points in our data set where a temperature measurement was recorded. So we have now been able to manipulate the plot formatting in that way. Probably some of this is fairly intuitive, like setting the X and Y axis labels. I think you probably get that idea pretty easily. But the style of the line formats might be a little bit less clear to you. So this style equals RO dash dash thing might not really make a lot of sense. But if you go to the documentation on the Pandas website, for example, and we'll do it like that, you can find there descriptions of the parameters that you can give when creating a plot, for example. So if you want, there is a separate color parameter that can be used to set the color of the line. And I think somewhere in here, in the Matplotlib, there's a link to the Matplotlib plotting documentation as well. And if you click on that link, you'll find other examples of how to format plots using Matplotlib. And somewhere on here, there is this thing FMT, and I thought at some place it actually gave you an example of the shorthand formatting. Yeah, so it's in the Matplotlib documentation that this thing we're using as style in Pandas. It gives you descriptions of like what this shorthand notation actually means. So usually it's given as like color, marker, and line. So color would be some letter that indicates what color the thing is you're plotting should be. Marker would indicate what kind of sort of symbol you want to use for the plot points. And then line, of course, is the formatting of the line itself. So then you can see here, for instance, with the markers, that we had used the letter O to make a circle marker. If you were like, no, that O's are sort of not my thing, I want to use squares instead, you could put the letter S in there, and then you would have a square marker instead. Or you can put an asterisk for a star, or X's, or whatever you might like. For the line styles, there's only 4 shorthand options that are available, which is to have a solid line, which is a single dash, a dashed line, which is 2 dashes, and then there's a combination of dash and dot that gives you a dash dot line, and then the colon character can be used for a dotted line. And then finally, you can find some information here about the colors. It's possible to use many other color options when plotting lines in Pandas, but this is the shorthand color options that are available to you. So this, I don't know, what is there, 8 of them or something like that? Anyway, you'll find that in the Matplotlib documentation if you want to know more about this style thing. But as mentioned, like when we produce the plot, if you said, I don't want to do circles, I want to do squares, you'd simply replace the O with an S. And when you produce the plot, then you would have square boxes instead. If you wanted to say, you know, I don't like red, I want to use a different color, like I don't know why you would want to, but if you wanted to do yellow, I don't find this to be a particularly nice yellow, so I wouldn't personally choose this, but of course you'd be welcome to. And if you wanted to have a dotted line, instead you could replace the 2 dashes with the colon, and then you get this dotted line with the kind of ugly yellow squares. So you can do your formatting and things like that in using this shorthand notation. You can also check out the documentation that's built in to using the Pandas plotting by doing things like help and oct1temps.plot. So this will bring up the documentation for plotting using the plot accessor in Pandas. And this is suppressed on the course webpage because this documentation is quite lengthy and detailed. But if you want to find something, most probably it is described in here. But you're going to have to be a bit patient. I think, quite honestly, in this case, it's better just to go to the Pandas webpage. It's much easier to navigate than scrolling through this very long text description of the plotting library that you can use in Pandas, as I'm still scrolling trying to get to the next thing we're going to look at. And you can easily imagine why we don't want to waste web page space with this output. Okay, seriously, there it is. All right, so we can also embiggen the plot for those who are Simpsons fans. That's my little call out to the Simpsons. We'll do basically the same thing that we did before. I'm going to type this in because I don't want to scroll back up to the top of the help documentation, but you can copy and paste this from the earlier cell if you want to save yourself time. So when we made our first little stylized plot, you can just copy paste that because basically almost everything is going to be the same here to make our plot bigger. I'll just type it in because, yeah, like I don't want to go find the other thing that we were just using. So I'll say style equals ro dash dash title equals Helsinki Vanta temperatures and X label equals date, Y label equals, and I think we had temperature in degrees C, no, degrees F. Okay, that's what we had before for the last plot that we just produced. I mean, other than the ugly yellow thing. But this is what we started with. To make the plot a different size, all we do here is add an additional parameter. In this case, it's called fig size. And then we're going to give in here, in a set of parentheses, the size of the figure in the always intuitive inches measurement unit. So this would make a figure size that is 12 inches by 6 inches wide. If you were to print it out on a piece of paper, I guess, you know, this is useful for those of us who are writing scientific articles because sometimes you have figure size restrictions and you want to be able to control the size of the figures. I don't find this to be a particularly intuitive thing to use when you're looking at your plots on the computer because 12 inches on the computer screen will depend on the resolution and blah, blah, blah. So whatever, we can use fig size to set the size of the figure that we want to have plotted. And if you add that parameter, and here we're going to set it to be 12 inches wide by 6 inches tall, you'll get a wider and tall, wider than tall plot now showing the same data that we had looked at before, but just formatted a little bit differently. So that is a handy thing, a frequent kind of thing that you would want to do because oftentimes you want to kind of change the shape of the plot as a whole, and you can do that using the fig size parameter. If you change either one of these numbers, like if you want to make it more, this won't make it exactly square, but close to square, you could choose 6 and 6. So that'll make your plot look more like this. Or if you were like wanting to, for whatever reason, to make it like kind of tall and skinny, you could do 6, 12. First number is going to be how wide it is. The second number is how tall. And again, this is probably not your preferred format for this particular example. But you could do, 10:5 or something like that, whatever you feel like. So that's how you change the style or the width of the figure. It's also possible to sort of set a default figure size at this in your notebook, but you have to import Matplotlib to do that. But that's another possibility. Probably better to do it on a figure-by-figure basis, to be honest. But you can set the default size as well. All right, a couple other common operations. One would be adding text to a plot. So oftentimes this annotation that you want to have on the plot is something you would want to add. We'll add that using ax.text. I'll show you an example of this in just a moment. But with ax.text, what you give is the x location, so the position along the x-axis, the position along the y-axis of where the text should be displayed, and by default it will be the lower left-hand corner of the text that should be displayed. And then, of course, in quotation marks, you would have the text you want to display itself. So we'll see how to do that down below. You can also change the range of the axes if you want to. So there's an xlim and ylim parameter that can be used. So xlim would set the limits for the x-axis, and then you normally would give a Python list that would have a minimum value for the x-axis and a maximum value for the x-axis. So you could, if you wanted to, use the entire data set that we had loaded in earlier and just set the axes limits to be different. It's going to be a little bit slower because you're plotting a whole bunch of data that doesn't necessarily need to be, or just dealing with a bunch of data that doesn't get plotted. So that's why we take the selection like we did. But you can use xmin and xmax and ymin and ymax to set the axis limits. The thing is that when you're dealing with the date time axis, like we have for the x-axis here, we have to consider one extra thing, which is the fact that the data on that axis will be in the date time format. So we have to give this character string like we did earlier to be able to handle our date time values. So we're going to use, for instance, to set limits, we would have to do things like do pd.toDateTime. And then you would give some character string there. Let's go with, I don't know, just to spice things up a little bit. Let's go with 2022, 10, 19, and 10, 13. So that's the current time. So the year, month, day, and then it's currently 10 a.m. and 13 minutes after 10 o'clock. Using this pd.toDateTime command, it will take this string, this character string, and convert it to a date time, in this case a timestamp, and you can see then the time. Of course, if you wanted to, there are other ways to get the current time using the datetime library, but this is just a way in which you can convert from character string to a datetime limit, which is needed when you want to have ranges like for your x-axis. So let's now take a look at a plot where we limit the time range that we're looking at to be from noon until 3 p.m. on the 1st of October. We look only at temperatures that are between 40 and 46 degrees Fahrenheit, and we add text to our plot to indicate the coldest part of the early afternoon. So our early afternoon here being between 12 o'clock and 3 in the afternoon. To do that, we can first make a variable here called start time. And our start time in this case will be pd.toDateTime. And we want this to be 12 o'clock on the 1st of October in 2019. So again, 2019 for the year. October is month 10. the day is 01, and then 12:00 for the time. That'll be the time that we want to start for our range that we're plotting. Then we can also have an end time. If you want to save yourself from typing things in, you can just copy and paste the line above and edit that, but I'll type it in just to take a little bit more time in case you're typing. So again, we do PD to date time, and this time it's year 2019, month of October, so 10, first day, and then 1500 for 3 o'clock in the afternoon. That defines some variable values we can use to set the axis limits. And then the cold time. Having done this before, I already know when the cold time of day is and where to put this. But of course, if you did this yourself, you probably would make the plot and then figure out after plotting it where you want to add this cold time text. But in our case, we're going to have it be at 12:05 on the same day. So again, 2019, 10:01, and then 12:05 for 5 minutes after 12 on the 1st of October 2019. Okay, so these are some times that we want to use to be able to modify something about our plot. Then we have here already what's been used earlier, that's been copied and pasted into place for you to save you from having to type that in. But we don't have our X limit and our Y limit defined here, so we need to add those. So in this case, we'll say xlim equals, and it will be a pandas list. And I'm just going to add the ylim equals thing here now, and I'll go back up. So our X limit, x-axis is our date. We want to go from start time to end time. That's why we define these variables. So we have start underscore time, comma, end underscore time. So that'll set our x-axis range to go from 12 o'clock to 3 o'clock when we plot the data. For the Y limit, you were mentioned or told above that you should have temperatures go between 40 and 46 degrees. The minimum value is listed first, so it's going to be 40, and then 46 for the Y limit. And then we have one last thing to add before we can see what this does, and that is to do ax.text, which is going to add our text annotation to the plot. We have cold time as the name of the variable that refers to where on the x-axis this cold time of day occurs in the early afternoon. The location along the y-axis, again, you wouldn't know this without producing the plot, but I can tell you from having done it before that it's at 42 degrees. And then the text you want to display itself, we'll make this look kind of nice by making a little fake arrow thing here and saying coldest temperature in the early afternoon. Whatever. You can type whatever you want there. You can just put cold or whatever. That's just a sort of text string. It's not really that important. You type the whole thing in. Okay. So what did we do? Well, we defined these times for different things we want to refer to in terms of time. We added x-axis and y-axis limits, and then we added the text to the plot. If you run the cell, what you'll see is now we have our Helsinki Vantaa temperatures. We have the range of dates that we're seeing are from on the 1st of October at noon to the 1st of October at 3 o'clock in the afternoon. Temperature range is from 40 to 46 degrees, and there's this nice little arrow pointing to the coldest temperature in the early afternoon. Of course, there are other ways to format this, but this is kind of where we're at right now with how we can format things. Are there any questions at this point? Or problems or concerns? All right, so I've been doing lots of talking, and now it's your opportunity to have a break from that talking and check on how things are going so far. So to do that, we will here give you the task that you should create a line plot similar to what we were looking at above, which, if I could give you a hint, would mean maybe you want to copy and paste what we did above, where your temperature data that you plot go from 6 p.m. to midnight on the 1st of October. The line that you have connecting these points will be a dotted black line, and that you should not show the data points themselves, but just have this dotted black line. Add a title that reads Evening Temperatures on October 1, Helsinki Vantaa, and then add a text label that indicates the warmest temperature in the evening on that day. So that is your task, and yeah, why don't you do that, and we'll continue once everybody is ready. I'm going to start by just selecting what was in the cell above when we made the plot that was just prior to this, copying that, and then pasting it in down here as a starting point. Because a lot of the same things that we need to do, we just did. So what are our sort of guidelines here? Well, we're told that we should start from 6 p.m. and go to midnight on the 1st of October. So I'm going to go here and instead of 12 o'clock for the start time, put in 1800. And then for the end time, I'm going to put in 00 and change the day from the 1st to the 2nd. There's other ways you can do this. I can't remember whether Pandas will be happy if you say 2400. We could try that approach. In fact, like let's just might as well try it and fail. Does it work? Yeah, okay. So I think it doesn't like when you put in 2400, which is a bit unfortunate because it is kind of intuitive to do it that way. So, but what you can do is you can put in midnight on the 2nd, which would then be that same time. We had a cold time before, but we're asked in this case to say what the warmest temperature was in the evening. So first, let's call that warm time. And in this case, the warm time, I'm going to put in as 2120. Of course, you may have put a different number there, but that's going to be what I'm going to put because, again, I have the solution here, and I know already what the warm time of the day is. We're also told that we should have a dotted black line with no data points. So, since we don't want to show the data points, I'm going to delete the O letter that's here. The black line is given with the letter K, which is probably not seeming that intuitive, but the default plot color in Pandas and in Matplotlib is blue, which is using the lowercase letter b. So b is already used for blue. So then the K for black as the last letter of black is used in this case. And it's supposed to be a dotted line, so we're going to delete the 2 dashes and replace that with a colon. We're then also given a title here that should read Evening Temperatures on October 1st, Helsinki Vantaa. I'm just going to copy that here and paste that in place of the existing title to speed things up a little bit. The date should be fine, the temperature should be fine, the figure size is fine, the X limit is already set, but the Y limit we may need to adjust because our temperatures might not be between 40 and 46, we'll have to see. But then where we place our label for the warm time and its value on the Y-axis should be instead of cold time, warm time, and 43 degrees instead of 42 degrees, and warmest temperature in the, let's say, evening. And actually, because of where this label is going to be placed, we'll put our arrow going the opposite direction. That's, again, something to just know from having produced the plot already earlier. So if I run this, Okay, it's not a total failure, but something has not worked out nicely here. It seems like we have things from 18 on the 1st of October to what looks like midnight, so that's all okay. But our temperature range is not looking so nice. So we're going to have to adjust our X limit here a little bit because something is not quite correct here. So let's fix a couple things. First off, we can make our Y limit. Sorry, I think I said X limit, but I meant Y limit. So this should go from maybe 35 to 44. Let's just rerun this with an adjusted Y limit. Okay, things are looking a little bit better. This text doesn't seem to work nicely. Well, that's because I had a shorter text string before. So the position at which the text is drawn was at, I think, 9:20 p.m., which is the point here. So it'd be the kind of lower left corner of where the text box is. And it looks like it needs to move over, I don't know, approximately this far, which I would say is maybe 30 minutes or something like that. So let's move it to be 30 minutes earlier to position the text properly. So that would be our warm time. It was set to be 9:20, and let's instead make it 8:50, so 20:50 instead of 21:20 for the last four numbers that are here in the warm time. Run it again, and okay, it could be maybe a little bit closer there, but you get the point. You can tinker with this stuff as much as you'd like. But that's the basic idea, just to play around with some of those different formatting parameters. A couple other things I'll show you, and then we are about due for a break, if not maybe even a little bit over the time for a break. So as mentioned, we've been doing line plots so far, but of course you can do other plots in Pandas too, including bar plots. I believe that this cell that's here, you don't need to do anything to except for run it in order to get a bar plot. The key thing here that's different from before is that we have this parameter kind equals bar in this case. So that's indicating that we have a bar plot for the style of plot or type of plot instead of the line that is the default. So if you run that cell, you'll see you get a bar plot that looks like this. Same kind of data that we were looking at before. Here we were going from 12 o'clock until 3 p.m. on the afternoon of the 1st of October. And now we've labeled the coldest temp like we did before, but now since it's a bar plot, we have a little V to point down for the location of the coldest temperature. So the main thing that's different here is basically just to add this kind equals bar, which will change the type of plot that is produced to make a bar plot if you prefer to use that. And you can find more about bar charts and how to format them on the Pandas webpage in their documentation. Once you have produced a plot, a common thing you're going to want to do is to save the plot image as a file. And to do that, we do have to bring in Matplotlib. So we're going to import the Matplotlib PyPlot library as PLT. Again, that's the kind of convention for using the PyPlot library with Matplotlib. Here we have the same plot that we were looking at just a second ago. This is the bar plot. And then there's also the bar plot text that was there before. All we need to do here is just add a command in order to save this plot to a file. And that command is called plt.savefig. And to keep it simple, all you have to do here is just give it the file name that you want to save your plot to. So let's call it barplot.png to save it as a PNG file. You could also put barplot.jpg or JPG if you like. The savefig method will look for this file extension and try to then save the file as a format that goes along with that. So if I press Shift Enter here, we see the plot get displayed like it did before. But if we go over now into the file browser on the left, and if I refresh, or maybe you don't even need to refresh the view, you now see this barplot.png file there. that was not there previously, and that's because we did this plt.savefig thing. And if I double click on that, sure enough, there's my bar plot image as a PNG file. So it works. If you want, there are some other parameters that can be useful to provide here. Among them is to add something to save the file at higher resolution. So this is a common thing if you want to put a nice looking figure onto a web page or into a thesis or something like that, that you would want to do plt.savefig. And then you can say, for example, the file name. Let's make this one a PDF file. So let's call it barplot high-res.pdf. And we'll also add DPI equals 600 to make a 600 DPI, or dots per inch, which is a quite high resolution PDF of our output plot. So different file name, and then we're adding the DPI equals 600. If you run that, again, you'll have to go over into the file browser to see the file, and you may need to refresh by clicking the little whatever circle with the arrow, refresh icon. And then you'll see barplot high-res is here as a PDF. Double click on that, and it might look like it's not a higher resolution image, but if you start zooming in by clicking the plus, you'll see that this is quite high resolution figure. Nice kind of crisp edges and things like that. If you compare it to the barplot.png file, and we zoom in a little bit there, you can see it's kind of fuzzy. So it's good enough to get us started with the barplot.png, but if you want to have a nice figure for your thesis, you're probably going to want to save it, for example, as a PDF or some other high resolution file format. I'm not 100% sure with Matplotlib whether some styles of plots will be written as vector images or as rasters. I think it rasterizes things by default, but I think it's possible to save some things like EPS files and others as a vector format, but I'm not even 100% sure how well that goes. I don't remember. So anyway, that's how to save the output files. Last thing we can look at here, again, you don't have to type anything in, but this is just to kind of give you a teaser of how to create interactive plots using hvplot. You can find some documentation on the course page to read a little bit more about what hvplot does, but for us, we can start by importing hvplot.pandas because we're going to use the pandas way of producing plots with hvplot. And then we have here, for example, a data frame where we're selecting dates for July of 2014. So you can see 2014 0701 at midnight, and then 2014 0731 at midnight as our range of dates. And this basically looks like what we did before. The only difference is that instead of saying whatever the data frame.plot, you say df.hvplot. That's it. So we have a title, we have X labels, we have a Y limit. All that stuff is the same as it works in plotting with pandas, but we just have .hvplot instead of plot. And if you run this, what you'll see is the data for the month of July in 2014 is now in the form of an interactive plot where you can kind of move along the plot lines and see individual values, for example. I think it's over here that you can get the little zoom tool. You can click and then zoom into some range to take a closer look at the data as you would like. And if you want to really zoom in, you can see things like this. I think you can click this little refresh button to get back to your original view. You can also set it to just pan through the data while we can see it all here. So the panning is not really necessarily that beneficial to us. But this is basically using bokeh in the background and very easily allows you to make these kind of interactive plots. We don't really have data other than the temperature to plot here. So, but you can see that by clicking on the label or the name of one of the columns that's plotted in the legend, you can kind of turn those data on or off, which is also a nice thing to be able to do, especially if you have multiple lines that are overlapping and things like that. In this case, our max and min temperature values, I don't even know if they're visible here at all because there may not be any for that range of dates that we have. But yeah, as you can see, it's not hard to make an interactive plot using hvplot. In fact, it's very simple to do it. And what's kind of nice about this, if I just scroll all the way down to the web page for the course in today's lesson, is that this is also an interactive document that comes from a Jupyter notebook when we produce the course web page. So you can do the same things that we were just doing. It's not a live Jupyter environment, but rather just on the course webpage. So if you're producing things and you say like, hey, it would be really cool to have an interactive plot on a web page coming straight from a Jupyter notebook, well, here you have an example that this is possible to do. It's really not that difficult. And there was nothing that we had to do to the course page to render this as an interactive plot when we produced the page compared to any of the other plots in today's lesson. So this is a nice thing to be able to do. And speaking of nice things to be able to do, I think it's time for us to take a break. And yeah, sorry for going a little bit long. I wanted to get through this first part of the lesson here so that we'd have a nice stopping point. But let's take 10 minutes, go stretch your legs, get coffee, do whatever you need to do, and we'll continue about 10:55.